Cloud native is microservices, containers, and serverless apps that run in multi-cloud environments and are managed by DevOps processes. But the relationship between these is not always clearly defined. Today I talk with Abel to discuss the relationship between all of this and to get a better understanding. Let's go find Abel and have a conversation about this to get a clear understanding. What's up, man? Good to see you.
Good to see you.
Hey, man, I am talking to my audience about cloud native apps, and I wanted to start off with DevOps.
Cool, that's what I do.
Sounds good. All right, so what is DevOps?
All right, so at Microsoft, DevOps for us is the union of people, process, and products to enable the continuous delivery of value to our end users.
All right, so why should I care about that when it comes to cloud native apps?
The key here is continuously delivering value, right? So one of the powers of cloud native is because all of your infrastructure is out in the cloud, you're able to iterate very, very quickly, right? That's what DevOps helps you do as well, continuously deliver value to your end users. The speed of business is so quick these days, if we can't iterate quickly and give value quickly, guess what? Our competitors will, and once they do, we're obsolete, right?
Awesome.
So this is super important for people to do. And cloud native really helps enable this.
So how is deploying and managing all of this infrastructure when it comes to cloud native, since we're all up in the cloud?
Yeah.
How's it different from something like, a mobile app that we might be developing, or maybe, a Windows desktop app? Because, historically, we're dealing with monolithic apps, or in the sense of maybe a Windows desktop app. I'm just creating that all in my code. I might have it in what we've done in the past was like, maybe source safe or something where we're dealing, with just the code. It's in our repo, and we might be doing just a standard deployment through maybe an MSI, where we're just installing that.
Right.
But now we're pushing all of that up into the cloud.
Yeah.
How is it different now with this process of managing all of these GitHub repos and really pushing it all up? So how's that process different?
So first, let me tell you what's the same, right?
Okay.
This concept of continuously delivering value, that's the same. The concept of, well, great, I want to check my code into one of my repos, and that should kick off a build. That build should have automation, right? It should compile all my stuff, package everything up, run all of my unit tests, and if everything looks good, then I want automation to pick those bits up and start deploying them through my environments, Dev, QA, UAT, all the way into prod.
Okay.
Right? So that right there, that idea is still exactly the same. But where cloud native becomes pretty unique is, number one, all your infrastructure is out in the cloud, right? So in some sense, deploying to the cloud is easier to do than deploying onto like a mobile app or whatever.
Oh, okay.
The other aspect is, one of the most powerful things about cloud native is, well, you're going to write a whole bunch of microservices, right? At the end of the day, it's microservice-based architecture. So in this fashion, we're able to iterate super quickly, because instead of deploying this massive monolith, if we make one tiny little change, if we do things correctly, we can just deploy that one service. Simplifies the process, speeds up the process. So now every developer check-in can go through our gates, can go through our pipeline, reach production at a quicker rate, right? So we're able to give value even faster and better.
Awesome. Let's grab a coffee and let's look at some of those concepts.
Sure.
Great. Let's sit down. Let's talk about some of the key concepts with DevOps and cloud native apps.
All right, so remember the whole idea is we want to continuously deliver value. Right? So one of the things we need to have is we need to make sure we have a CI/CD pipeline. A pipeline that will take our code. As soon as somebody checks it in, I want to be able to build it and then deploy it all the way out into whatever infrastructure that I have out there.
Okay, great.
Right. So the example that we're going to look at, this is a cloud native application. It's actually a pretty simple application, but the infrastructure is a little bit more complicated.
Great.
It consists of a static website that is held in Azure Storage. It also has a back end. The back end is written in .NET Core. and it's held in an Azure function.
Okay.
Right? And they both connect up to a Cosmos DB.
All right.
So it seems pretty simple, right? So as soon as somebody checks in their code, remember one of the concepts for cloud native is, if possible, it sure would be nice for us to be able to deploy just each individual microservices on their own. Right? That's one of the powers of microservices, and it really can help speed things up.
Okay.
But there's a problem with that. If I am going to deploy my microservices out independently, my services need to be smart enough to realize what version is each other on so that I don't break the entire application just by uploading one new service. Right?
Great.
So if my code's not ready, what does that mean? I have to deploy my entire infrastructure all at once. Right? So clearly, I don't want to do this forever, but since I'm just starting this application, none of my services can talk to each other in that fashion. So right now, I want to deploy my entire infrastructure all at once.
Okay, so let's see what that looks like.
All right, so when you look at this, I have a whole bunch of repos that I'm creating that I'm going to go ahead and use, right? I've got my infrastructure as code. I also have a DNS checker function that I'm deploying as well. This is going to check DNS for me and things like that. And then I have my front end code and I have my serverless backend code.
All managed in separate GitHub repos.
These are all in separate GitHub repos.
Awesome.
And they're all connected in the sense that as soon as somebody checks in that code, it's going to go ahead and kick off the build for just that particular service. Right? So if somebody checks in code for the front end, it'll just kick off that front end build.
Okay, so I as a front-end developer, I can do my work, not worry about a back-end, not worry about whoever's managing the infrastructure, right? And that's the whole purpose of this disconnected, non-relational between the two, that I can just do my job and not have to worry about who's doing the other things, right? But the DevOps relationship between all of these individual services is that puts that relationship together between the two and manages that process automatically.
Manages that entire pipeline for you, right? And it's not just the code. If you look at this build, the very first step, it looks like I'm deploying the infrastructure, right? Because that's literally what I'm doing. Remember, one of my repos is holding my infrastructure as code.
Okay.
So this entire infrastructure that we just described, the Azure storage, the Azure function, right? The Cosmos DB. And also we're routing a bunch of stuff, so we're using Azure Front Door as well.
Okay.
All of that infrastructure is captured in our infrastructure as code. So we can start from nothing. We can start from completely empty Azure subscription. And as soon as this build hits and it starts running through the pipeline, the very first thing it does is it starts deploying my infrastructure for me.
Okay, so that takes the actual DNS relationships and that's actually building that up. And that's the first thing that has to happen before anything else gets deployed.
I can't deploy my code if I don't have the infrastructure.
Oh, great.
So in this case, I have my infrastructure. This first box here, I'm going to deploy it's going to deploy the infrastructure for my web front end. So it's going to create my Azure storage for me. It's going to create the infrastructure for my function. Then it will go ahead and create also my Cosmos DB.
Okay. So how do we know? What do we put in? You've got a check DNS beta job here.
Yes.
How do we know that that's ready before everything else goes? What's the dependency before everything else gets done?
Okay, so notice I have 3 parallel deployments going on at the same time. And these two, the infrastructure DNS, so this is, I'm actually deploying out all of my DNS settings to, I think I'm using Cloudflare this time.
Okay.
Right, so it says, okay, this is a new CNAME and all that stuff that we put in there. This DNS checker, this is an Azure function, and this function is smart enough, well, basically it just queries DNS to say, hey, did your information propagate from Cloudflare all the way down to my local DNS instance? Right. So what I end up doing is these two, when they're done, it goes into this DNS checker state, where I'm using a post-deployment automated deployment gate. In this gate here, we'll go ahead and ping my DNS checker to say, hey, did DNS update? And if it did update, hooray for that pass. And if it doesn't, go ahead and wait. So when you set this up, you can set like the polling frequency. So I'm saying, every 5 minutes, let's check the DNS. And you also say, how long do you want this to run for?
Okay.
So I'm
something
saying
like 24 hours.
24 hours, and if it still hasn't propagated in 24 hours, something has gone wrong.
Okay, great.
So this will sit here at this check DNS beta state, and it will ping the DNS until DNS actually returns. Right? And the reason why I need to do this is because when I deploy my front door instance and then configure that front door instance, there are some configurations inside of front door where DNS has to have propagated for the configuration to work. Right? So not all situations are where you have to wait for the DNS to propagate. There are some things where you can just blast all the code in.
Sure.
But for this example, that's what we had to do.
Okay.
But so this entire block here, that is all just deploying that infrastructure and setting everything up and wiring all the stuff together through front door, my functions, my web app, front end, all of that, right?
Okay.
And when that's done, I go ahead and deploy my application. So that would be here, my front end beta and my back end beta.
Okay.
So deploying the front end, remember this is just a static website, so literally I'm just packaging up the files that I need to into a zip file and I send it over to Azure Storage.
Okay, in this case it could be anything. So this is just a static website, it's running on Azure Storage.
Yep.
It's probably something like a Vue app or it can be just static web files, HTML files, and we're just placing it there. So that's just one step.
That's just one step. And so this is really a Vue app.
Okay.
Right. And then I go ahead and deploy my backend. Deploying the backend is equally as easy because remember, we're deploying a .NET code into an Azure function.
Okay.
So it's just one app service task. Deploy this into this particular app service, and hooray for that, we're done. And when both of these are finally done, then we get to a manual approver gate, where, of course, I'm making myself the approver. But basically now I get to say, hey, now that the app has been deployed into my beta infrastructure, let me go ahead and test it and make sure it looks right. And if it looks right, I can go ahead and approve it. And as soon as I approve it, it then flows on over into my production state. Right? So my production stage, notice my production stage, I do the same type of stuff. First, I need to deploy my infrastructure for the front end, the infrastructure for the back end, then deploy the code, and then hooray for that, then I'm done. Right?
So would you say that the DevOps in this particular situation is kind of like the glue? We're gluing all of our steps, all of our infrastructure, all of our code together, and that's really the relationship that we have here. And looking at your flow that you have here, this is kind of an initial stage, but if I was just to make a simple change to like my .NET Core Azure function, could we have a flow that's maybe parallel to this that says, this is an update. We know that our DNS is good. We know that our front door is set up, and I just want to make an adjustment. Do I have to go through this whole type of a flow, or is there another concept where we can say, we know it's an update, everything else is check, 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 and I just need to go ahead and post an update?
If you know it's an update, you can just deploy to whatever particular stages you want to.
Like a feature flag almost, right?
Yeah.
Okay,
Yep.
perfect.
So you don't have to deploy it all at once. And in fact, as soon as we add some more code, right, so that our services will communicate with each other and be like, so if I'm the web front end querying my back end, I can be like, what version are you at? Oh, you're on version 2 and not on version 3? Oh, then I'd better just run the version 2 code on my end, not the new version 3 stuff because you don't have it yet. Right, so once we have that type of code in place, then we can just deploy the microservice and not the entire stuff all at once.
Got it.
Right.
So I want to step into a scenario that probably you and I, we've been in this business, we've seen monolith applications, we've done the right-click publish, but I want to kind of paint the scenario for us, right? I know that you and I, we didn't work at the same company in the past, but we probably lived the same stories where our QA and our production and our development environments didn't match, right? We had one dev box probably under our desk. We had two maybe QA, and as we went to production, those environments didn't match.
Right.
Okay. So how do we ensure quality across our environments in a DevOps practice type of situation?
One of the coolest things about being a cloud native application, that means our infrastructure all runs in the cloud, which means, notice I'm using infrastructure as code, right? So as I go from one environment to the next, the very first thing I do is I go to my infrastructure as code files and say, hey, deploy this infrastructure for me. So now we are absolutely guaranteed that my dev environment is exactly the same as my QA environment, exactly the same as all the way out into production.
Oh, okay.
And it's cost effective because we can just spin it up, run whatever we need to, and as soon as it's done, tear it down so we're not paying for it anymore.
Right. And I could really manage all of my apps using containers as well. I mean, that's one of the beauty of cloud native.
Yep.
We're using containers. I have all of my dependencies inside of that. Now in this particular situation, we're not using containers. Serverless kind of helps us out in that situation.
Yep.
The front end app is just a kind of a static HTML.
Yeah.
We could wrap that in containers, but that's kind of like shipping your blog on a semi type of thing, right?
Right.
But we could manage that infrastructure that way.
Yeah. We could have done this all with containers, but it's such a simple application.
Yeah.
Right? It literally is static website, one Azure function. It seemed like containers would be a bit overkill.
But this is almost the simplest form, if you will, of a cloud native application.
Absolutely.
Right?
Yep.
We are using the cloud in our serverless. And we are managing our environments.
Yep.
We could add a QA and a dev and a production and a test environment, right?
Absolutely.
We could do all of that. But again, like you said, this is very simple. But it does set the relationships up for us across all of our infrastructure, in our code, in order to kind of grow up from there, right?
Yep.
So let's move forward a little bit. How much can you really automate this? You've got a couple of manual steps in here, and I've built some pipelines, playing around in here where I get an email that says, hey, approve this, and I'm kind of blindly go, sure, push it forward, I'll deal with the problems later. Can I really automate all of these types of steps? You said you've kind of self-approve.
Yeah.
Could I have multiple approvals where you do it and maybe I send it to Susie and Susie says yes and then it has to go up the chain? How much of this can we really automate with this process?
So this is super cool because you can automate almost everything, right? But I do like having manual approvers when I go from one environment to the next environment. I want to have someone actually check it to make sure it looks good. Right?
Okay.
Within Azure DevOps, the tool that we're using to build out our pipelines, there's the concept of an automated approval gate as well, right? So you can use automation to help you decide, oh, should we go on to the next stage or not, right? So I'm using an automated approval gate to do my DNS check. Has DNS propagated or not?
Okay.
Right. So before we had this automated approval gate, for the DNS checker, that had to be a manual approval step, right? Stop right here, don't do anything, check DNS, and when it finally propagates, then say I approve, then it can go on, right? I can save myself this manual step now because I have this automated gate that can do that for me.
Sure.
However, when I finally deploy into my beta environment, I still want someone to look at that. I still want someone to be like, yes, I give it my blessing before it goes on.
Right. Okay.
So the idea is I want to automate as much as I can. Is 100% automation possible? I don't think the goal is for 100% automation.
But we could include things like, as far as automation, we could put in testing, right? I deploy it.
Absolutely.
I could deploy it to my QA. I could run a bunch of tests. Have that have that as a block in here. It says run my test, and then still have that manual gates, right? So we can insert those manual spots where we want to.
Absolutely. So trying to keep quality in your pipelines, that's really difficult to do as well. So yes, you can do things like, let's go ahead and run all of my tests, my automated UI tests for this particular environment. So by the time, let's say I deploy this into a QA environment, by the time my QA testers even look at it, it could have run through like hundreds, thousands of automated UI tests already. So there's much less that a human being needs to do.
Okay, perfect. Is there any other concepts that we haven't touched on, just kind of wrap up this session here, that you think are important to mention when it comes to building cloud native apps? And we've talked about kind of using actually cloud native practices here, like you've used a serverless function to check your DNS, right? You're kind of using cloud native to check your cloud native.
Yeah.
All right, so to wrap this up, is there any other things that you want to touch on other than just go check it out?
Just do it.
All right. All right, so that wraps up our session on cloud native apps using DevOps. For any other information, be sure to go check out the show notes. Thanks for joining us. Thanks for watching the Cloud Native Show. Be sure to subscribe, watch for a future episode, and especially our streaming shows on Twitch, where we build apps based on the conversations had right here. We'll see you next time.